So problem number 7. It says we're planning to make an open rectangular box from an 8 by 15 rectangle. So this is 15. This is 8. So to make an open rectangular box, you guys had an extra credit assignment similar to this, I believe. You need to cut corners. Yeah, Jacob actually brought it today in class. It's such a good project. That's your open box.
Is it locked?
And when we Alright, there's our rectangular box, where the height of that box, we'll call that, this is x, and this is x, 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 x. Right? So we cut in some x amount. So the volume of the box, so volume is normally base times width times height, or something like that, length times width times height, whatever you want to call it. So the base, that's x. This, let's use the side. So that will be, it was 8, and we take off how much? 2x. And this piece was 15 minus 2x. So our volume now becomes 15 minus 2x, 8 minus 2x, times x. Every optimization problem is exactly the same in the sense that you get an equation in terms of one variable, you differentiate that equation, set it equal to 0, solve. So let's go ahead and we'll expand this out. So 15 times 8 is what? 120 minus 16 minus 30 minus 46x plus 4x squared. Is that right? 16 and 30?
Yeah.
Times x, and now distribute the x. So 120x minus 46x squared plus 4x cubed. Now we're going to differentiate. So this equation is as x changes. So x is the amount you're cutting. So depending on the length of your cut with your scissors, you plug that length into this equation, and it will tell you the volume of that box. That's pretty cool. And then we differentiate. And this will tell me how the volume changes as the length of our cut changes, as x changes. That's what this means. So this becomes 120 minus 92x plus 12x squared. Set this equal to 0. Divide everything by 12. I think 12 goes in everything, right? Maybe?
No.
No, it doesn't go in 92. 6 go in everything? No. 2 goes in everything?
1 does.
Oh, 4? Okay, good. Why did I skip 4? 32. That doesn't make sense. 30 minus 23x plus 3x squared. Does this factor?
Yeah.
No.
Yes.
No.
Yeah, sure, it is.
Maybe.
Nope.
No, yes, it's prime. How decisive.
Which one is it?
No.
No.
It's
Okay.
definitely no.
So, yeah, we could use a calculator or the quadratic formula.
No, you didn't.
Negative b plus or minus square root.
Oh, I like that enthusiasm there. 23 plus or minus square root of b squared, so 23 squared, that's 529 minus 9360 all over 60. I think that's right? 23 squared, someone check?
Yeah.
Okay. You guys know that trick?
Wait, isn't A zip zoom?
I didn't do zip zoom this now. If you just square numbers, you go like this. You go multiply this way, that's 9. Multiply diagonally, and then add your results. So 6 plus 6 is 2 with a 1. The 1 you carry. Then multiply this way, 4 plus that 1 is 5. That's right. I'll show you what I just did this. What I did with arrows is the same as this.
When does that work?
All everything, all the time.
What is it that's doing it?
That's when you're adding fractions. Yeah. So I just FOILed it. I thought 20 is 20 plus 23 is 20 plus 3. 23 is 20 plus 3. All that stuff. Okay.
You ruined it, Ross.
Still no idea. So I'm gonna be over 60.
Oh man, it didn't say that. The battery's
2A.
almost empty.
Oh yeah, you're right. A is 3, so 6.
No, it's counting up.
And then we've got 169. Oh, so it does factor. You guys.
I said maybe.
I told him. Did I not say yes?
I just wanted to see the quadratic formula in action.
Sure you did.
Let's go back and factor.
So by the way, whenever you do the quadratic formula and the radical goes away, that's telling you that you couldn't factor it if you were clever enough. Which we clearly are not.
Should have taken.
Or if you just didn't want to say it.
So that's 6, 4,
1.57.
5, 6. No, 5/3.
Oh, high five.
Let me guess, you guys got it right.
No, he got it
Okay. Now, I got 2 choices, but I'm not done. Because I'm trying to figure out which of these cuts. So I can cut in 6 inches. Is it inches? Is that what we're doing?
Yeah.
Or 5/3 inches. Which one will maximize, and how do we know?
Well, I was just saying, weren't we dividing by 60 earlier? And then we
I
dropped
lied.
it.
I was wrong because
Oh, yeah.
3 was the A. Yeah, normally we had it written backwards. Yeah, Paul?
It's 5/3 because it can't be above 4 because the small side is 8. And if x is bigger than 4, you have a negative side, which can't happen.
That's a really logical way of doing it. This doesn't make any sense, right?
Yeah.
Because the other one was how long?
One of them was 8.
8. So if you cut 6 on both sides,